Ever stop to think why you're not just, like, poof, annihilated by an antimatter version of yourself? Seems like a basic thing, right?
Huh. Yeah, apparently the universe is terrible at basic bookkeeping. Welcome, everyone.
Welcome to the deep dive.
It really is a fundamental cosmic screw-up. We call it the Baryon Asymmetry problem.
Right.
Basically, the Big Bang, all our physics says it should have made equal parts matter and antimatter, perfectly balanced.
But it didn't, clearly.
Exactly. Look around. It's all matter, overwhelmingly. So, what the hell happened to the other half? It's genuinely one of the biggest head-scratchers in physics.
So today, we're giving you the shortcut, the quick guide to this puzzle. And trust me, the ideas physicists are throwing around, they get pretty wild, maybe even audacious.
Oh, definitely audacious. So let's start with the classic approach. Back in '67, Andrei Sakharov laid out these 3 conditions. Kind of a checklist for how you could end up with more matter than antimatter.
Okay, what's on the list?
Right, first, baryon number violation. Fancy way of saying the rules have to allow for matter particles to just, appear or disappear. The total count isn't fixed.
Okay, rule 1, conservation laws can be bent.
Got it. Second, C and CP-symmetry violation. This means particles and their antimatter twins don't always behave as perfect mirror images under certain transformations. There has to be some subtle bias, some favoritism towards matter.
A cosmic thumb on the scale.
You could say that. And third, these things have to happen when the universe is out of thermal equilibrium. Basically when things are hot, messy, and chaotic early on, so the imbalance doesn't just get smoothed out again, it needs to lock in.
Makes sense. So we had the checklist, problem solved.
If only. See, the inconvenient truth is our current best theory, the standard model of particle physics. It just doesn't deliver.
Doesn't cut it.
Not even close. It does have a tiny bit of that CP violation, number 2 on the list, but it's orders of magnitude too small. Like, ridiculously insufficient to explain the sheer amount of matter we see.
So the standard model basically shrugs its shoulders.
Pretty much. It means we need something new, something beyond the standard model, which honestly feels a bit like saying magic happens here.
Like needing a bigger Band-Aid, yeah.
Exactly. And people used to float this other idea, remember? Maybe the antimatter is just somewhere else, like hiding out in distant antimatter galaxies.
Yeah, that always felt a little too convenient, like sweeping the problem under the cosmic rugs.
Totally. Too neat. And turns out, if those galaxies existed, the boundaries where they meet regular matter would be spectacularly bright. We'd see a buttload of gamma rays from all the annihilation.
And do we?
Not a peep. Our telescopes see nothing like that. So yeah, that idea is pretty much dead, deemed unlikely.
Okay, so the old ideas are insufficient or busted. What's next? You mentioned audacious.
Right. This is where it gets really interesting. Or maybe just, out there, depending on how you look at it.
Lay on us.
Okay, picture this. The CPT-symmetric universe model. The idea is the Big Bang wasn't just one explosion creating our universe.
Uh-oh. Where's this going?
It was maybe a double-sided event. Our universe, full of matter, expanding forward in time like normal, but created at the exact same moment, is a mirror twin anti-universe, full of antimatter expanding backward in time.
Backward in time? Whoa. Okay, that's bold.
It's wild, right? But the beauty is it preserves this really fundamental symmetry called CPT-symmetry. Charge, parity, time. Flipping all 3 together should leave the laws of physics unchanged. This model respects that perfectly, just globally.
So the universe is balanced.
Yeah.
Just not the bit we can see. One side matter forward, one side antimatter backward.
That's the core idea. And it's potentially game-changing for a couple of reasons. First, it kind of tells the prevailing inflation theory to take a hike.
Inflation. The universe expanded super fast right at the start.
Yeah. This CPT model argues inflation is like adding Ptolemaic epicycles, just extra complexity and arbitrary knobs to twiddle to make things fit. They say this twin universe idea is simpler, more elegant, a bit of a burn, really, to inflation theorists.
Okay, shots fired. Yeah. What else?
Well, and this is maybe the mic drop moment. It might solve dark matter. For free.
Seriously, how?
The model sort of naturally generates these things called sterile right-handed neutrinos. Sterile just means they barely interact, hence why they're dark, and it seems to produce them in roughly the right quantity needed to be the dark matter.
So no need for exotic new particles, just these neutrinos.
Potentially. It's called the most economical explanation. And there's even a tiny tantalizing hint from an experiment called Anita down in Antarctica. It saw some weird signals that could fit with these specific neutrinos. Very tentative, but
interesting.
Okay, wow. Simpler explains matter-antimatter and dark matter. Sounds almost too good. What's the catch?
There's always nuance, isn't there? Quantum uncertainty means the two universes wouldn't be perfect mirror images, which is actually good, philosophically.
Not so.
It avoids strict determinism, leaves room for randomness, maybe even free will. Things aren't just an exact replay forwards and backwards.
Okay, that's convenient. It is. But the model isn't perfect yet. It currently struggles a bit to explain the large-scale structure of the universe. How galaxies are clustered. Inflation actually does a pretty good job there, so it's still a work in progress.
Right. Science, always evolving.
Always.
So, wrapping this up, what's the takeaway for you listening? The universe is either fundamentally lopsided, a glitch we haven't figured out,
or it's actually deeply symmetrical, just in a much, much weirder, more, dare I say, trippy way than we ever imagined.
a universe with a past-flowing antimatter twin. I mean, what does that even imply?
Yeah.
About cause and effect, about...
Exactly. Maybe the cosmos just really, really digs symmetry, even if it has to bend time itself backwards to achieve it.
Definitely something to chew on. Thanks for diving deep with us.